Okay. So actually I have put another example in class notebook under example number 4. So this is another example. Okay, this one. Okay, example for beam analysis with support settlement. So please take a look of this example. So I have given actually one example, one video example, so you can find the okay okay this one, and another one is this. Okay, so please take a look of this for you to do your summative 1.2. Okay, so we move to this one. So the one that we have actually discussed yesterday. Okay, this is the frame, Sidesway frame. We know that this is Sidesway frame because the frame is unsymmetry. Okay, unsymmetry due to loading and due to geometry. Due to either one, also we have to consider it as Sidesway frame. Okay, so this is unsymmetry and it is not it is unrestrained. Okay, it is unrestrained, so this frame is tend to sway to right direction by looking at the 200 kilonewton, which is located at B. So the frame is tend to sway to right direction. So in order to solve this, okay, always remember that we have because in the distribution table, the first member and moment in the table is actually fixed end moment. And fixed end moment, we can divide into two conditions. One is external loading, another one is delta for frame. Okay, we consider as Sidesway delta. Okay, Sidesway frame is delta. For beam, normally is support settlement. Frame also can have support settlement, but because the analysis is actually similar with beam with support settlement, so we skip that one. Okay, you can apply support settlement in frame also. Okay, but in that case, frame without Sidesway. Okay, frame without Sidesway can have support settlement. Okay, and for this one, this is frame with Sidesway. How we know that this is Sidesway frame? Because of the geometry and because of the frame is unrestrained. Okay, unrestrained means we put roller, we put support to become some sort like wall. Okay, to restrain the frame from move. Okay, means that B and C, when we have support like this, support C, so that is why we have to know what is the definition of properly restrained. Okay, properly restrained means this. Okay, properly restrained means that if the frame is tend to sway to right direction, so we have to put support. Okay, to put pin support, and from the pin support there will be a restraining force which is called as R. Okay, so our intention is only to the restraining force which is in horizontal direction, R. Okay, this R will become wall. Okay, so that this frame is now called as properly restrained. Properly restrained means no movement. Properly restrained means we have removed the delta from the system. So when we have properly restrained, we can calculate end moment by only considering external loading. But since this diagram B is not equal to diagram A, because in diagram A has combination of external loading as well as delta. So by applying principle of superposition, we will have another diagram. Okay, another diagram where this frame is the same geometry without external loading, of course, but this time it is due to R. Okay, it is due to R. So because the restraining force R that comes with support at diagram B has to be neutralized. Means that there will be a restraining force in opposite direction. In opposite direction means in right direction. That is why the frame is tend to sway to right direction. So due to R, there will be delta. Okay, there will be delta, and of course in this C diagram, okay, it will have end moment, and end moment due to R and due to delta is called as M. Okay, end moment due to R, end moment due to R, and due to delta, okay, is called as M. M. Okay, for diagram B, okay, due to external loading, we will calculate FEM, and from FEM we will do distribution moment in the table, and the moment that we get from this diagram is called as M naught. M naught. And due to the M naught, the end moment that we get from table, we will calculate R. And R that we calculate based on table 1 will be used in diagram C actually. Because in diagram C, we cannot directly calculate moment. So what we should do next is to introduce another frame diagram, okay, which is proportional, which is proportional. So this diagram C and diagram D, okay, is the same diagram, proportional. So we have to draw another diagram, but this diagram is subjected to R prime, and due to R prime, there will be delta prime at position B, and at position C, it is a horizontal displacement because, okay, we have to refer to the column. So Sidesway referring to the column, beam is always follow the where the column move. Okay, and due to R prime, due to delta prime, we will analyze end moment. This is table number 2, and end moment for table number 2 is labeled as M prime. So in these two diagram, when we compare these two diagram, what we have is actually, okay, M1 we get from table 1. Table 2. M1 we get from table 2. Okay, from bukan M1, M prime. Okay, M prime we can get from table 2. M prime is actually end moment. Okay, end moment. How we get this value? From assumption, from FEM that we assume in this, okay, in this frame, in diagram D. Okay, and then after having end moment from table 2, we calculate R value. Okay, R prime value. So in diagram D, we have M prime, we have R prime. Okay, both of these we can calculate, and we need to compare with diagram C. And in diagram C, we have M and R, where M is unknown and R value is known value. How we get this R value? We get from table number 1. This is table number 1. So R value we can get, okay, we can get when we do static equilibrium analysis, we can get R value from M naught value. Okay, so these are, okay, these are will be using in diagram C. Okay, in diagram C. So what we need to do is we have to compare these two diagram with M and R under C diagram, and with, okay, M and R under C diagram, and with M prime and R prime under D diagram. We can have, or we can make interpolation. Okay, we can write relationship between this. So what we get is like this. Okay, it is M divided by R prime. It is M divided by R, okay, equal to M prime divided by R prime. So we know that the unknown is M. This is M. So we rearrange back. So we rearrange back and we write like this. R is it is R divided by R prime. It is R divided by R prime times with M prime. So this will be M. Okay. M is equal to R divided by R prime times M prime. So we can conclude that okay, whenever we substitute M, we substitute into this. Okay, because to calculate the final end moment, by applying principle of superposition, it is A equal to B plus C. And the label for end moment, final end moment that we want is M final, MS, we label as MF. And then the end moment for diagram B, is M naught, we get from table number 1, and M, okay, from diagram C. So it is M final equal to M naught plus M. And when we substitute M, where it is R divided by R prime times M prime, so we substitute, we get this. So we get this as the final equation. So we can summarize all the steps like this. Okay, so in frame with Sidesway analysis, I can divide into 4 main steps. Okay, so step number one, of course, we have to calculate K and DF as usual, and K and DF will be used in both table number 1 and table number 2. Move to step number 2. Step number 2 is called as non-sway frame analysis. Non-sway frame analysis. Okay, and under non-sway frame analysis, remember that the criteria for non-sway frame analysis is it must be properly restrained. So under non-sway frame analysis, it must be properly restrained. Okay, so what is inside this number A? Okay, A, we have to calculate FEM. 2A FEM, this one due to external loading. External loading. Okay, B. Okay, B. After FEM is end moment. End moment. Okay, end moment. This is table number 1. This is table number 1. We label as M naught. Okay, we label as M naught. And C. And C is R. Okay, restraining force. Restraining force. R. So we need to calculate restraining force R. Okay, this is the second step. Okay, step number 3. Step number 3 is called as Sidesway frame. Sidesway frame analysis. Okay, it's called as Sidesway frame analysis. So 3A is FEM. FEM due to Sidesway. Due to Sidesway or delta. Okay, FEM, and this is based on assumption. Okay, we will assume FEM for one member and we will calculate for another member. Okay, next we repeat again. Okay, the difference is only at step A tu. 2A dengan 2B. That's the only difference. Okay, next we repeat the same process. Okay, end moment after FEM is end moment. We cannot combine because FEM due to delta is unknown. Okay, this is end moment. Okay, end moments. This is table number 2. Table number 2 yang ni I put delta prime because it is due to R prime. Okay, this is table number 2 and this is M prime. Okay, and step C, we need to calculate restraining force. Restraining force R prime. Okay, and finally the last step is to calculate final end moment. Okay, final end moment. What is the formula? The formula is M final is equal to M naught plus R divided by R prime times M prime. Okay, this will be the final equation. The final equation where M naught is come from table 1, M prime come from table 2, and R divided by R prime is called as correction factor. Correction factor. So we will, okay, for remaining 40 minutes, okay, we will try to analyze this. Okay, we will try to analyze this. Do you have any question so far before we move to, okay, the solution for this one? Do you have any question? Do you?
So far, no, doctor.
Okay, clear tak the explanation, the concept?
Clear.
Clear, doctor.
Ya, kejap. Saya nak switch this to Excel. Okay, wait, I need to switch, okay, the screen. Okay, can you see my Excel?
Yes.
Yes.
Okay. So we will start with table number 1. We start with table number 1 here. So we start with member. And then after that what? K, K. So I calculate K in the table directly. So this is K in terms of EI. So EI, you don't need to substitute EI value whenever you calculate distribution factor, stiffness factor. Because once you calculate distribution factor, EI will be cancelled. So do not wasting your time to substitute EI into the stiffness factor formula. Okay, so just remain as EI in terms of EI. Okay, so we have three members, mean we have 6N. So start with AB, BA, okay, nampak kan? Okay, AB, BA, BC, and then CB, and then CD, and then DC. So K for AB, we use 4 EI over 4. It is 4 EI over 4, right? So it is equivalent to 1. Okay, and then we have another 4 EI over 4 for BC. And we have 3 EI, 3 times 2. EI over 6. 3 times 2 is 6. 6 divided by 6, so equal to 1 also. Am I right?
Yes.
Okay, so we move to distribution factor. Distribution factor for fixed is 0. Distribution factor for pin is 1. Okay, pin is 1. So the rest is 0.5. 0.5, 0.5, 0.5. Okay, now move to FEM. This is table number 1. FEM due to external loading. FEM due to external loading. Okay, FEM due to external loading. So we have 60. W is 60, L is 4, so WL square over 12. WL square over 12. It is 60 times 4 square over 12. Oh. For BC, BC, it is negative. W is 60. Times 4 divide by 12. We get negative 80 and 80. Okay, so we will start with the first distribution. So distribution number 1. Okay, the first distribution. Okay, for joint B, this is joint B. Joint B. Okay, this is joint B. Okay, we have to find the total moment. The joint moment is this times with factor. Okay. Times with factor. Joint moment times with factor. Okay, yang ni actually no value. Kalau ada FEM, then you need to calculate. Okay, so carry over. It is carry over, step carry over. Okay, step carry over, this is equal to 40 divided by 2 because the factor is 0.5. The factor is 0.5. This one join C. Okay, join C. Join C. Okay, so this is also 40 divided by 2. Okay, 0.5. And then this one is negative 40 divided by 2 cross boundary. This one is 0. Okay, when distribution factor is 1, distribution factor is 1 because it is n pin, the factor is 0, so it will be equal to 0 lah for carry over step. Okay, continue distribution number 2. Distribution number 2. Okay, distribution number 2 look like this one is okay, yang ni easy lah because the factor is equal, right? Okay, so just copy this. And then okay, carry over. Distribution number 3, carry over. Distribution number 4, carry over. Distribution number 5, carry over. Distribution number 6, Okay, last is distribution. So this one I will delete. Okay, so yang ni okay, format cell to set decimal places up to 3 decimal places, and this is M naught, yeah, this is M naught, this is M naught. And moment for table number 1, and moment for table number 1. It is like this. Okay, so total start from the first end moment in the table, which is FEM. FEM, so total. So yang ni format cell number 3 decimal places. Okay, so this will be the answer. Okay. Hari ni 21 hari bulan 21 hari bulan 4. Okay. Okay, do you have any questions so far? Is it okay?
Yeah, doctor.
Okay, so we want to move to table number 2. So I copy this one. Okay, copy. This is table number. Okay, so now in table number 2, okay, the one that we should change is FEM. So the FEM, okay, we will change to FEM due to Sidesway. Okay, yang ni kita nak remove. Yang ni kita nak change to FEM for table number 2. So yang ni saya clear content dulu. Okay. Okay, we go back to this. Okay, now concentrate on diagram D. Concentrate on diagram D. This is the diagram. Concentrate on diagram D. Okay, sini. This is diagram D. Okay. So it is 4, 4, 6. This is 4, 4, 6. 4, 4, 6 and EI, and 2 EI, right? This is EI. This is EI, and 2 EI. Okay? Okay, we have to actually assume FEM for one member. So the member that we should assume FEM is only column. Okay? Sidesway relate with column. Beam will only follow wherever the column move. Okay? So we have column AB. This is column AB. Okay, this is column AB. Triangular. So always find the triangular. This is column AB. So this is column AB. So this is 4 meter length. This is 4 meter length. Okay, 4 meter length. So this is the delta. The delta. So new position of beam of column after Sidesway. Okay, this is new one. This is new. Okay, so okay, mark the angle. Mark the angle from original position to new position. The angle. It is clockwise. It is clockwise. So we apply back the concept. Same concept that we apply in beam with support settlement. When angle is this label. So when angle is positive means FEM negative. Okay, because FEM concept dia is we will apply FEM to push back the column to its original position, and original is vertical. Original is vertical. When we have this, so when we want to make this to straight back to vertical, we have to apply in this direction. So this will be followed. That is why FEM for AB. So this is A, this is B. Okay, this is B prime. Okay, this is B. Okay, FEM for AB will be the same for AB and BA, and okay, it will be negative because of the behavior. It will be negative because of the behavior. Because if we have this, okay, this column after Sidesway, if we apply wrong sign, means if we apply moment, okay, okay, this one is negative FEM. This is negative FEM. This is negative FEM. This is positive FEM. Okay, which one is the correct one? Okay, the correct one. To remain stability. Is it A or B? The behavior. Which one?
A.
So A is the correct one. A is the correct one. So FEM for AB must be assumed as negative value to represent the behavior. Okay, the moment. Moment we apply to remain stable, to remain stability. So we have to apply the right sign. Okay, the right sign in this condition is negative. Okay, negative to push back the point, the new position, the B prime to original position. So what we need to do is we have to assume FEM. Okay, we have the same sign for FEM AB and BA. Okay, and it must be equal to negative, and the value suggested by the textbook is 100 kilonewton meter. Okay, FEM for Sidesway frame we have to assume. So how to assume? We have to choose one member only. Choose one member and assume FEM for that particular member. In this case, I choose FEM AB, FEM BA equal to negative 100. And then what we need to do next after this is apply the formula. Formula for Sidesway for or delta is 6EI delta prime, in this case delta prime divided by L squared. This is the formula as written in the textbook. L is 4, right? L is 4 squared. So this one is equal to negative 100. Negative 100. So we rearrange this. So we get EI delta prime equal to negative 100 times 4 squared divide by 6. Okay, divide by 6. So by using this EI delta prime, okay, by using this EI delta prime, we calculate FEM for CD. We calculate FEM for CD. So CD is like this, CD. Okay, original is like this. This is CD. Okay, this is CD. So this is C and D. C and D. So new position C prime. Delta is delta prime. Length is 6 meter. And it is 2 EI, right? 2 EI. 2 EI. The angle, okay, the angle is, okay, the angle is again positive angle. Positive angle means negative FEM. Positive angle means negative FEM. Okay, so having this triangular, we continue to calculate FEM for CD, which is equal to FEM for DC. Okay, FEM for DC. Okay, and of course, you can also use FEM directly by considering N pin, which is equal to this only. It is okay, it is 3 EI 3 times 2. This is the formula. The formula to calculate FEM for N pin is 3. The difference between N fixed dengan N pin, okay, is only 3 and 6. So kalau FEM for N fixed is 6 EI. This is the formula. Delta over L squared. Okay, 3 EI delta over L squared. Okay, this one is for N fixed. And this one is for N pin or roller. So we can also use the right, okay, the real formula. But if we use this formula, make sure that FEM, it is for FEMCD only. It is only FEMCD, not FEMCD equal to FEMDC. Okay, if we want to use this, so it is 3 times 2 EI. Okay, 3 times 2 EI delta prime divide by L is 6. L is 6. Okay, L is 6 square. So this is 6 square. So what we need to do is, okay, substitute. We will substitute this into this. So when we substitute, what we get is 3 times 2 divide by 6 square times with yang atas tu, it is negative 100 times 4 square divide by 6. Divide by 6. So what do we get? So this one cancel, this one cancel. So what do we get? What is the answer for FEMCD? FEMCD? It is 100 times 4 square divide by 36. 1600 divide by 36. What do you get? Betul kan? So it is
44.444.
44.444. It is negative. It is negative 44.444 kilonewton meter. Kilonewton meter. Okay. So we have we have FEMAB, FEMBA equal to negative 100, and we have FEMCD equal to negative 44.444. FEMDC is equal to 0 because we use this formula 3. Okay, faham yang tu? If we use 6, we will have CD and DC. Okay, move to this Excel. Okay, move back to this. Okay, move back to this. So we have negative 100 for AB and negative 100 for BA. And then we don't have FEM for beam because for beam as a horizontal member, beam yang ni, beam dekat sini. Sini kan, BC and CB, beam as a horizontal member, the shear force, okay, is in vertical direction. So we will measure the vertical displacement for beam, and there will be no vertical displacement for beam in this case. So that is why the value is 0 for FEM, AB, BC and CB. Okay, there will be no movement, no vertical movement. Beam, yang ni beam, BC. Okay, yang ni delta dia, no vertical movement. Delta is equal to 0. Okay, delta is equal to 0. That is why we remain as 0. Okay, and CD is negative 44.444. Okay, yang hujung tu 0. Okay, so by putting this, so what we get? We get, okay, wait. Okay, so we get n moment. So this is m prime. This is m prime. This is m prime. So we get this negative 76, negative 52, positive 52, 34, and negative 34. So this is table number 2. Table number 2. This is table number 2. So I will copy this back to the OneNote. So yang ni. Ada soalan tak sampai-sampai tu? Do you have any question? Nampak tak? Okay, the difference between these two tables is only due to FEM. One is due to external loading and another one is due to Sidesway. Okay, for table number 2, the FEM will be based on assumption. That is why in the final formula we have correction factor. Okay, we have correction factor. Okay, I put the table here. Okay, so this will be table number 1. Okay, ni table number 1. Table 1. This will be table number 2. Table number 1 and table number 2. Okay, so for table number 1, so we will analyze R value and R prime. R value and R prime, table number 1, okay, table number 1 will be based on diagram B. Table number 1 will be based on diagram B. Okay, this is for table number 1. Table number 2 will be based on diagram D. Okay, diagram D. So for table number 1, copy this first. Okay, actually to determine R and R prime value is the same process, okay, using two different table, table 1 and table 2. Okay, so for table number 1, this is the frame. This is the frame. Okay, this is for table number 1. Okay. So what we need to do to analyze this is first we need to draw the free body diagram. Means that we have to apply. Okay, this is fixed. Okay, at A there are three A tu ada apa? 3 unknown reaction. So we have to draw all that. Okay, so ada AX. Sini ada DX. And then ada AY DY. Ni ada AY DY. And then ada moment. Moment is positive. So this is moment. Okay. Okay, so you have to label all the reaction label at A, reaction label at D. So this is A. So we have AY, AX. AX. This is AY. This is MA, which is equal to this value. Okay, and then we have DX. DX and DY. So this one is DX, this one is DY. Okay, by analyzing this, okay, this is non-sway frame lah. This is non-sway frame. Non-sway frame. Okay, the properly restrained frame. So what we need to do is we have to number 1, write the shear equation. Okay, write shear equation number 1. Okay, we have to write shear equation. Okay, shear equation. Okay, shear for column. Shear for column means in horizontal direction. So it is total Fx is equal to 0. And by looking at the diagram, we can write an equation. Okay, an equation. What is the equation? By looking at the diagram, relates all horizontal forces or horizontal reaction in the diagram. Apa dia? It is apa saja horizontal reaction and horizontal forces. We want to write the shear equation. Shear ni relates to column. And shear for column is in horizontal direction because we want to find this value. So we have to write whatever equation which include R because our target now is to calculate R value. Kita dah masuk step ni, step tadi, step okay, we want to calculate this restraining force. So our target now is to calculate restraining force. We have two restraining force under step 2 and under step 3. So if we want to calculate R and R prime value, we have to analyze the diagram. Okay, we have to analyze the diagram. So we have to understand that table number 1 reflecting which diagram, and we have to analyze the diagram. We have to analyze the diagram and write whatever equation that will include R, so that R will be the unknown that you will calculate. So that is why by looking at this diagram, we find that that shear equation will include R into the equation. So what is the equation?
200
Okay, it is 200
plus AX
plus AX
minus DX
minus DX
equals to R.
equals to R. Okay, so this is the equation. Okay, this is the R equation. Okay, so under this equation, we have another two unknown. Okay, two unknown. We have AX and we have DX. We have AX and we have DX. So how to calculate this AX and DX? Okay, to calculate AX and DX, we have to apply what we call as column analysis. Column analysis. Column analysis ni explain in chapter number 11. Column analysis, about column analysis. This is column analysis. We have to analyze column A, B and column CD separately. Column A, B and column CD separately. So for column A, B, we have, okay, it is 4 meter. It is 4 meter length. Okay. And for column A, B, draw back all the, okay, AX. Okay, AX only included. AY does not give any difference because kita nak ambil moment nanti. Okay, this is AX. And then moment at A. Moment at A, so this is AX. Moment at A, kita ambil yang ni lah, nilai moment 26.641. 26.641, we put into the diagram, 26.641. Moment is 26.641. So this is AX. Okay, this is A and B. Okay, so how to calculate AX? How to calculate AX? A moment at B. We have another one, moment at B. Moment at B, this is moment at B, 53.32. Okay, we have moment at B. It is positive 53.32. Okay, analyze this column to determine AX. What will we get? What should we get? Taking moment at
B.
Okay, taking moment at B. Taking moment at B equal to 0. So what do we get? It is 53.32 plus 26.641. 641 minus right, minus 4AX equal to 0. So AX equal to this one. Divide by 4, right? Divide by 4, it is 53.32 plus 26.641. What is the answer?
19.99.
19.
Yes.
19.99
Yes.
kilonewton. So this is AX. Okay, continue to calculate, to analyze column CD. The same thing. Okay, column CD, we have 6 meter length. We have we have dx. We have dx like this. Dx. This is dx, right? Dx. Okay, and moment. Moment at C. Here. Negative 34.076. Negative 34.076. So we have to apply into this in negative direction. Negative 34.076. 076. So if this is D, this is C. So taking moment at
C.
okay, by taking moment at C, which is equal to 0. So what do we get? Dx is equal to 34.076 divided by 6. So we get
5.679.
12.6.
5.
5.
5.679.
5.679 kilo Newton. Okay, so this is AX, this is DX. So we substitute into R. Okay, substitute into shear equation. Substitute into shear equation. Yang ni substitute, yang ni pun substitute. Okay, so what do we get? So R is equal to 200 plus 19.99 minus 5.679 equal to
214.311.
311 kilonewton. Okay, so this will be R value. Okay, the same process. Okay. Bukan. Tadi ambil salah kolom lah. Kejap. 34 bukan yang ni. Yang ni Kan? It is 53.32, right? Buka balik 53.32, it is negative. $53.32. So this will be 53.32. 53.32. So calculate again. This one.
8.887.
887. Yang ni lah. 8.887.
Yes.
Okay, 8.887. So calculate R value.
211.103.
103 kilo Newton. Okay, so this is R value. R value. Okay, so we have to repeat the same process. Okay, repeat the same process. Okay, using this as MAB, this as MBA, and this as MCD, using the same concept. Okay, the same step. Okay, you will do the same. Of course, the second diagram is referring to diagram D. Okay, you will do the same. Okay, repeat the same process and you will get R prime value. So finally you will calculate R, or you will calculate R divided by R prime as the correction factor. Okay, dah pukul 1 dah. Can you continue to repeat the same process? Okay, to calculate R value, R prime value, and then substitute into the formula. Okay, so we have done calculating this. We have done calculating this. We have done calculating this. So remaining is R prime. Repeat the same process. Okay, you just need to analyze diagram D. Put all the free body diagram. Okay, include AX and DX like the previous step. Okay, and then using column analysis, calculate AX prime and DX prime, and then calculate R prime. Okay. Any question before we end this session?
So far, no, doctor.
Okay, so it is actually what is called as moment distribution method frame analysis, frame with Sidesway analysis. So the most difficult part is actually under step 3A. Okay, under step 3A where you need to yang ni step 3A where you need to calculate FEM, to assume FEM and then calculate FEM for another column or another members based on what you have assumed. And then once you get all the FEM value, substitute into the table and you will get the end moment M prime, and then for step 2C and step 3C is actually the same process. Okay, in order to determine the correction factor. And once you have all this, okay, M naught, R prime, R and M prime, you just need to substitute into the final formula to calculate final end moment. That is all about frame with Sidesway analysis. Okay, is it okay?
Okay, doktor.
Okay, doctor.
Okay, doktor.
Okay, so yang tadi tu video tu ada yang saya share tadi tu, video yang saya share dalam general channel tu, you can actually watch that in order to enhance your understanding. Okay, in order to enhance your understanding. So actually it is just, okay, kejap, saya on camera kejap. Okay, it is actually like this. Okay, it is not as simple as beam. It is not as simple as beam, but you need to understand the concept of Sidesway, and then you have to be able to assume the right FEM and calculate FEM for the remaining members. Actually the one that you calculate, tadi kan kita assume column AB 100 and then calculate for another members. Yang tu actually is ratio only. So we want to calculate the value of FEM whenever AB, okay, AB is equal to negative 100. What is the ratio? Okay, so for that one, yang akan influence dia is EI and then length and then delta. Okay, so frame with Sidesway for straight column yang ni lah yang saya cerita hari ni. So in next video saya akan cover include one incline column and two incline column yang maybe kita tak touch in class, tapi saya akan buat video untuk cover so that you have material to for you to prepare for your summative 1.3. So by today or tomorrow I will give to you the question for summative 1.2. Okay, 1.2 and lepas tu saya akan bagi 1.3 lah, 1.3. So that next week we will start with new chapter, flexibility method. Okay, if you have any question you can text me under Teams chat ya. Teams chat, insyaAllah I will answer. Okay, so nanti saya akan post juga macam biasa. Saya akan bagi you 1 week untuk buat formative formative, so that saya boleh semak dulu whether it is correct answer. So if you got correct one, so you boleh submit for summative. Okay, so that is all for today's session. So insyaAllah we will meet again next week. Okay,
Thank you, Doctor.
Thank you very much. We close this session with Tasbih, Kifarah and Surah Wa'as.